Hello guys, welcome back to the CCNA video series brought to you by ABY Design and Tech. In this video, we're going to focus in on router on a stick configuration, so let's get started. So before we go to the CLI, let's have a look at the play-by-play for switches and routers. Now on a switch, we would need to configure our VLANs first, because obviously how can we route between VLANs if they don't exist? Then obviously we would need to configure our ports which go to our endpoints, our laptops, our access points, our cameras as access ports. So interface number, switch port access VLAN number again. Then the link, so the interface which links our switch to our router, that would have to be configured as a trunk link, because obviously we need to carry traffic from multiple VLANs over a single link. And then if you want, we could do some VLAN pruning so that we can kind of like cut down the allowed VLANs over that trunk link. Now on the router, it's pretty straightforward. We just configure our sub interfaces with the command interface. Now obviously you would choose the physical interface which links your router and switch together, and then you would use that in this command. But essentially the command is interface, in my case, fast Ethernet 00 dot, and then just choose a number. Again, this is just an arbitrary number. This is just to identify that sub interface. This does not have to match the VLAN number, but of course logic dictates that it should, because it makes so much sense. If you're troubleshooting or if you're looking at some configuration, it's just so easy if the sub interface number matches the VLAN, because you could be like, oh, okay, that sub interface is configured for that VLAN, etc. And then to actually assign the sub interface to a VLAN, we use the command encapsulation.1q number. Again, this would just route, though this number is important because it relates to the VLAN. And then we would just configure an IP address on the sub interface, and it's as simple as that. Literally just a few commands, and then we've got routing over a single link between our VLANs. Now the topology we're going to use is going to be the same topology that we saw in our base configuration video. We're going to have a device in VLAN 10, a device in VLAN 20. My laptop that I'm recording from, that is going to be in VLAN 10. Then we're going to have a single link running between our switch and our router. So FA0/8, that's going to be the interface on the switch. We need to configure that as the trunk link. And FA00, that's going to be the interface on the router. And then all we would do on the router, we would go in, create these sub interfaces, and then obviously VLAN 10 has to be assigned the sub interface, the IP address of 192.168.10.1, because obviously the router is going to act as the default gateway for these devices, so we have to give it the IP address of the default gateway. So now I'm going to pause the video. The next time you see my screen, I will be at the CLI of a Cisco switch. So I'm now on the CLI of a Cisco switch. Again, before I do anything, I'm just going to prove to you guys that I can't actually ping the device in VLAN 20. So I'm in VLAN 10 at the moment. If I issue the command ping 192.168.20.10, this is going to fail. So as you can see, I'm not getting any responses back, because at the moment there is no communication between VLANs. So on the switch, I've already configured my access ports. I'm going to do a show run interface. Let's go FA0/1. And as you can see, this goes to my laptop, and FA0/2 that goes to the other laptop who is host 2. So back in our topology, it was fast Ethernet 08, which connects or links our switch to our router. So that will be configured as a trunk port. We enter global configuration mode, interface FA0/8, switch port. So on my switch, I have to tell it to use .1q encapsulation. On newer switches, they only support .1q encapsulation and not ISL. Switch port mode trunk. That's it. And then switch port trunk allowed VLAN. So if I really want to be granular about what VLANs can pass over this trunk link, I will configure my allowed VLAN list. So 10, 20. Now at the moment, that's interface. If I go show IP interface brief, show IP interface brief, at the moment FA08, that's currently down at the moment. The reason being is because by default, any interface on a router is shut down by default. So now let's move over to router R1 and let's configure that with sub interfaces. I'm back on R1. Let's verify this configuration. Show IP or show run interface FA00. So this is the interface which which physically, not logically, which physically links my switch to my router. That's currently shut down at the moment. So, what configuration has to go under the interface, under the physical interface? Well, literally all we need to do is just bring up that interface, and then we would configure our sub interfaces. That's going to be it. We don't need to have any IP address configured on the physical interface. Now you can, so if you configure an IP address on a physical interface, and obviously that physical interface has got multiple sub interfaces, then by default, as long as you have no sub interface configured for the native VLAN, that physical interface the switch would assume that that physical interface is assigned to the native VLAN. Now, obviously, if we have a sub interface already configured for the native VLAN, then the physical interface won't be assigned to the native VLAN. But in my experience, I literally just leave that physical interface blank, no IP address. I may configure it with a description, but I usually just bring it up. So literally just enter the no shutdown command. Interface FA00, let's go no shutdown. So let's bring that up. Now let's configure our sub interface. FA00.10. Configure this. So encapsulation.1q. So before you configure it with an IP address, you have to tell the router what VLAN so tell the router what VLAN this is being assigned to. In this case, VLAN 10. IP address 192.168.10.1 255.255.255.0. Interface FA00.20. Encapsulation.1q20. IP address 192.168.20.1 255.255.255.0. Yeah, I've already got a IP address configured on FA0.1. Let me just shut down. So shut down. Let me just bring that down. No IP address. Interface FA00.20. IP address. So so the reason why that command failed, I already had an IP address in that subnet configured on FA001. That's why it rejected the command. 192.168.20.1 255.255.255.0. So now if I do a show IP routing table, or show IP route, this shows me the routing table. As you can see, the router believes that it can reach the VLAN 10 subnet and the VLAN 20 subnet by using the sub interface. It doesn't even see the physical interface. So with router on a stick, we're effectively tricking the router into believing that it can reach these VLANs via the sub interfaces. It doesn't actually realize that traffic, so from a logical point of view, physically obviously he knows that he has to forward the traffic out that physical interface, but from a logical point of view, he believes that it can use these sub interfaces to reach those VLANs, when in reality it's going to be that physical link, the physical interface, which is going to be carrying that traffic. So let's test this out. Let me see if I can ping my laptop first. That was successful, brilliant. Let me make sure I can ping the host in VLAN 20. Okay, successful. Now the moment of truth. Let me see if I can ping the device in VLAN 20. So 20.10, this should work. And just like that, it's worked. So just like that, we have a single link between our switch and our router, carrying traffic for all VLANs. And again, if I go back over here, as you can see, it identifies that to reach these subnets, it can use the sub interface. Now, if I do a show IP interface brief, do you think the sub interfaces will appear in this command? And they will. So as you can see, the router treats them as separate interfaces. That is the reason why we can configure an IP address on those interfaces in different subnets. Because logically speaking, he believed that they connect to separate broadcast domain. In reality, we're still using that FA00 interface to carry that traffic. So under the FA0 interface, just to go over it again, there's no configuration needed apart from we just need to bring the interface up, and then we would go ahead and configure the sub interfaces for whatever VLANs we have. So guys, router on a stick is really that easy to configure. Next up, let's look at configuring switch virtual interfaces. If you have enjoyed this video and would like to see more content like this, then please subscribe to my channel, and thank you very much for watching.